Today I'd like to talk to you about the force of gravity. The force of gravity is one of the major things for unit number 2. I do not expect you to become an expert in gravity from today's notes. We'll be looking at it in more detail over the next few days, but I would like you to have some basic understanding of gravity at the end of today's video. So the first thing I want you to understand about gravity is that gravity occurs anytime you have objects with mass. If you have two objects with mass, there will be a gravitational force pulling those two objects together. This force is often so small that we don't notice it. We don't feel ourselves getting pulled to the refrigerator. Well, sometimes we do. But the gravitational force between normal size objects is something that is very hard to measure. However, when the objects get as big as the sun, or the earth, or the moon, gravity becomes readily apparent. And in fact, all objects with mass pull on all other objects with mass. So you can see the sun is being pulled toward the earth as it's pulling the earth toward it. We can see the sun is also being pulled toward the moon, and the moon is being pulled toward the earth. Again, these force gravities act between all objects with mass to different degrees. When you find the net force, you may find that the force from the sun is much more significant than the force from the moon. Doesn't mean that the force from the moon doesn't exist, and it doesn't mean the force from the moon isn't important. It's just dominated by the force from the sun. Okay, so if we have two planets or two large heavenly bodies, in this case the sun and Saturn, how do we know how strong gravity is going to be? Well, it turns out that there are 3 factors that determine the strength of this force. And if you can imagine, they are the mass of one object, the mass of the other object, and how far apart the objects are. When you put the objects closer, gravity will become stronger. When you make the objects more massive, gravity will become stronger. Okay, so what you do is you need to measure how far apart the objects are. Notice I measure from the center of one object to the center of the other, not surface to surface, center to center. I measure that distance in meters. And I also need to know the mass of these objects. So we'll call it the mass of object 2 and the mass of object 1. These are the factors that determine how strong of a pull these objects will have on each other. Bigger masses will make a stronger pull, and a bigger distance will make a weaker pull. Okay? This was first discovered by Isaac Newton, and you can see he published this idea of gravity in his book called The Principia, which was published in about 1687. He named this phenomenon gravitas, okay? You can see Newton was from England, and you can see the years that Newton was alive. What Newton realized, because after all, everybody knew gravity existed. It wasn't like he invented gravity or discovered gravity. What he realized is that the gravitational force felt by an apple and the gravitational force felt by the moon were caused by the same phenomena. They were both caused by the pull of the earth. He reasoned that all mass attracted all other mass with a force that depended on how much mass and how far apart they were. He actually came up with a formula that we can use to calculate this force that involves those 3 factors that we just talked about. The force of gravity depends on how heavy is object 1, which might be the earth, how heavy is object 2, which might be the apple, and how far apart are those objects. When you measure, you want to make sure you put your mass in kilograms. You want to make sure you put your radius in meters. And then our gravitational constant is what we use to make sure that the units work out right. Okay, it kind of measures the strength of gravity in our universe. How will these kilograms and meters create a certain amount of newtons of pull? And it turns out that this gravitational constant wasn't discovered for quite some time after Newton died. So he wasn't actually able to use his formula. He just did it based on how he felt these factors should affect gravity. Turns out he was correct. And it turns out that this gravitational constant is 6.67 e to the negative 11. And again, it will get the units to work out properly. You will have this accessible to you. I will post this on your Google Classroom. And anytime you need to know the masses of things, like Saturn and the Sun, you can get them from this column that says mass. It also tells you how big the object is, and more importantly, how far these different objects are from the Sun. Or if they're moons, how far they are from their planet that they're going around. So make sure you know how to read this. Mass of the object, how big is the object, how far is it from the object that it is orbiting. Okay, so I'd like you to actually try and do some of these problems. And we'd like to do the one with the Sun and Saturn. So I'd like you to take a few minutes, write out your formula, and plug in the numbers. I'll get you started, but I'd like you to do the rest of this work on your own. And again, the numbers are posted on Google Classroom for the mass of the objects and how far apart they are. I'd then like you to try another one where you figure out the force of gravity between the Earth and the Moon. So that's where I'm going to leave you, and I will actually put the answers to these so you can follow along, but try it yourself first. It doesn't do you any good to just copy what I have done.